Good morning. So what we're going to be working on today, we're just going to work on a couple of Webassign questions that I've noticed we're having issues with. And so the first one I'm going to start with is number 12 from Webassign. So I'll label that. So this is Webassign 5.4, which is all about our sum and difference formulas. So the first one we have here, sine of arctangent of a 5x minus arc cosine of x. So first thing I want to do, anytime I see what this is called a composite function, if I see inverse trig inside of a composite function, best thing I can probably do is draw a triangle. So because it's almost Christmas, we're going to draw a triangle for arctangent as being red. And so let's go ahead and draw one of those. And then we'll draw a triangle for our cosine to be green. So nice holiday cheer there. Okay, arctangent is arctangent of 5x. That's basically saying if I have an inverse trig function, that's basically saying the output of whatever angle I have is going to give me 5x. So if I think about what tangent is, tangent's equal to y over x. And in this case, I know that y over x is going to be equal to, did not give myself enough room here, y over x is going to be equal to 5x. Well, I would like to know what's the denominator in this case. So if y over x is equal to 5x, well, technically 5x is over 1. So I could say that the x value, the horizontal, is going to be 1, and the y value is going to be 5x. So all I need to do is solve for the hypotenuse. We'll call it r. So 5x squared, and remember it's the whole thing's being squared, plus 1 squared is equal to r squared. And so I know that 25 x squared plus 1 is equal to r squared. I'm going to take the square root on both sides. That's going to undo the square. And I'm going to take the positive square root because I know that radii or hypotenuses or, any of those things, they represent distance and they're not going to be negative. And so we're going to make this square root of 25x squared plus 1. Okay, we got the first triangle done. Let's do the next triangle. Next one is about cosine. All right, so the next one we're going to do all of our work in green. I know that cosine, if I said arc cosine of x, that's saying that there is some value that gives an output of x. Well, I remember that cosine is equal to, an x by r definition, it's equal to x over r. So I know that regular x is equal to x over r. So if I put a denominator on that, we could say the denominator is 1. I know that the radius or the r value is going to be 1, and the horizontal or the x value will be x. So I need to find the other value. We'll call it question mark. So I know that question mark squared plus x squared is equal to 1 squared. And so question mark squared is equal to 1 minus x squared. Take the square root of both sides, and this missing value, question mark, is equal to 1 minus x squared. I'll take the square root of that. And so this y value right here is going to be the square root of 1 minus x squared. All right, very, very festive. I'm super excited to solve this. Next thing I want to do is I want to use the sum and difference formulas. So I'm going to go ahead and copy and paste those in. Okay, so here are the sum and difference formulas. They're right back in here. So basically, I just want to use some of them, like a S-U-M. I'm going to use some of them. Actually, that's an S-O-M-E. I'm going to use some of them to figure out how can I rewrite this in terms of just one angle, the sine of just one angle, plus or minus the sine of just another angle. In essence, I'm trying to write this as an algebraic expression. I don't want to have any more of these sines or tangents or arctangents or cosines. I want to write this all in terms of just x's. And so I can totally do that. I'm just going to pick the one that applies. So the one that applies, if I'm looking at this whole thing, too dark. The one that applies here, sine of arctangent of 5x minus arc cosine, that looks like it's in the category of sine of a minus b, which means I can rewrite this whole thing in terms of that identity. We can say that arctangent is going to be a, and I'll make it red, and arc cosine is going to be b. I'm going to make it green. All right, so what I have is this whole thing is equal to sine of a, but remember a is the arctangent of 5x, and then times cosine of b. So cosine of b, and b in this case is going to be arc cosine. Ooh, that's interesting. Okay, arc cosine of x minus, and I'm going to have to get rid of this at some point, minus cosine of A, which is, in this case, arctangent. Let me actually just get rid of this, which is arctangent. Cosine of A. And then we're going to say times sine. Oh, I don't want to write that in red. It's going to be confusing. Times the sine of B. And in this case, B is the green, which is arc cosine. And the reason I'm doing these colors here is, I don't know if you guys have seen my previous videos, but I do have a tendency to get these confused. So using colors is always a helpful strategy. All right, let's go ahead and evaluate. All we need to do is use the triangles at this point. So I want to know, hey, what is sine of arctangent 5x? Well, that's the same thing as me saying, hey, what's the sine of the triangle? So remember, sine is equal to opposite over hypotenuse. You could also say it's equal to y over r. So the sine of this triangle is going to be opposite, using this as my angle, which is 5x over hypotenuse, which is square root of 25x squared plus 1. So that was sine of the triangle. Let's go ahead and find cosine of arc cosine. Those are inverse functions. If I take the f, say if I know that I have inverse functions here. If I say f of f inverse of x, the property of inverses is that if I compose them together, I'm always going to just get the plane variable out, x. So for example, if I took x squared and I took the square root of it, I would just get x out. Square root, sorry, plus or minus, square root and square are inverses. If I compose them together, I just get the original x out. And so this actually just cancels to x. So I'm going to put an x here. All right, minus. All right, cosine of arctangent. Once again, that's red. So I'm going to say, hey, what's cosine of the triangle? What's cosine of the triangle? Cosine is equal to adjacent over hypotenuse. So I'm going to say 1 over the square root of 25x squared plus 1. And then sine of arc cosine. Okay, so I want to know what's sine of the green triangle. What's sine of the green triangle? Sine is equal to opposite over hypotenuse. And so I can say that this is going to be equal to the square root of 1 minus x squared, that's the opposite, over hypotenuse. So all we need to do is clean this up, and we are going to be so close to being done. So if I clean this up, I'm going to get 5x squared all over the square root of 25 x squared plus 1 minus 1 all over the square root of 25x squared minus 1. So I hope you guys notice here we have the same denominator, and so I can combine the numerators. So 5x squared, oh man, almost caught me there. I forgot to put on this square root of 1 minus x squared. Almost got me. All right, so 5x squared minus the square root of 1 minus x squared all over the square root of 25x squared plus 1. And so that right there is going to be our solution. And hopefully if we write it correctly, it will be accepted in Webassign. All right, so that one right there was, once again, this was question number 12. So let's go ahead and keep on going. Let's try question number 13. All right, so question number 13 here says this. Write a trigonometric expression as an algebraic expression. This is the same process here. So I'm actually going to pause just because I don't want this video to last forever, and I'm going to make some triangles. All right, so I kind of kept with the festive theme today, and I did a red triangle for arc cosine, and I did a green triangle for arc tangent. So notice the same process is applied here. Tangent's equal to y over x. I know arc tangent is of 6x is me saying, hey, I have some value that gives an output of 6x, because remember, inverses switch input with output. And so I said 6x over 1, giving me 1 for x and 6x for y. And then I solve for r, and I did the same thing for the red function. So all I want to do now is I want to use the identities that I know to go ahead and solve for this. So I have cosine of arc cosine of 3x minus arc tangent of 6x. So I'm going to kind of translate that into arc cosine of 3x is a, and arc tangent of 6x will be b. So I want to go ahead and rewrite this using an identity. So I have an a minus b. Okay, well, a minus b looks like this one right here. So let's go ahead and use it. So I'm going to say that this whole thing is equal to cosine of a. Okay, and I know maybe this is annoying that we're keeping all these colors, but it really helps sometimes. So we're going to say cosine of arc cosine of 3x. And then we're going to get, let me go back. And then we're going to get cosine of b. Well, cosine of b in this case is going to be arctangent of 6x. And as always, I'm going to run out of room. Plus sine of a times sine of b. So sine of a in this case is going to be arc cosine of 3x. And I do need to move that at this point. We'll just get rid of it. Times sine of b. Times sine of b. Okay. Times the sine, and b once again is green. So I'm going to keep that in green. So the sine of b is the arctangent of 6x. The arctangent of 6x. All right, so let's keep on going here. I want to know, okay, cosine of arc cosine of 3x. So once again, the property of an inverse is that if I compose an inverse with its inverse, I am going to get just the inside out. And so in this case, I'm actually going to get 3x out. So if I said f of f inverse of 3x, what I would get out is just 3x. So whatever the inside is, I'm always going to get that out. In essence, the inverse undoes this whole f of whatever, and I'm left with just whatever the function has on the inside. Typically, we usually see x, but in this case, we see 3x. All right, let's keep on going. Arc cosine of arctangent. Okay, so what I really want to know is what is cosine of the green triangle? Okay, well, cosine of the green triangle. Let's go ahead and make sure we know what angle we're looking at. Cosine of the green triangle is going to be adjacent, which is 1, over hypotenuse, which is square root of 36 squared plus 1. So we're going to say 1 all over the square root of 36x squared plus 1. All right, let's keep on going. Plus sine of arc, oh, I didn't even write it down. Sine of arc cosine, my bad. Sine of the arc cosine. So that means I want to know, hey, what's the sine of the triangle? What's the sine of the triangle? Well, the sine of the triangle is going to be equal to opposite over hypotenuse. So in this case, it's going to be the square root of 1 minus 9x squared all over 1. And then lastly, times the sine of the arctangent. So I want to know, hey, what's the sine of the green triangle? Sine of the green triangle is going to be opposite, which is 6x, over hypotenuse, which is the square root of 36x squared plus 1. And so if I combine these all together, I get 3x all over the square root of 36x squared plus 1, plus 6x times the square root of 1 minus 9x squared, all over the same denominator of 36x squared plus 1. Since they have the same denominator, I can combine the numerators, so I get 3x plus 6x times the square root of 1 minus 9x squared, all over a common denominator of 36x squared plus 1. And that right there is the solution. Hopefully if we put that in Webassign, we get a correct solution out. All right, let's go ahead and move on to the next one. Okay, so guys, so for this last one here, I kind of already worked it out. Just for time's sake, I want to keep this video a little bit shorter. This is question number 11 on Webassign. I noticed a lot of us also don't have this one done. So what we can write here for this question is we have cotangent of u plus v. Well, cotangent of u plus v, I don't have an identity. If I think about my identities, oh, it's already there. I don't really have an identity that deals with that. I don't have that. I only have tangent. But if I use yet another identity within an identity, so I know we're getting to like crazy matrix zone here. I know that cotangent of x is equal to 1 over tangent of x. And so what I could write is, and this is what I did in my first step, what I could write is this. Cotangent of u plus v is the same thing as tangent 1 over tangent of u plus v. So I know that our fractions might get a little bit crazy here, but what I did is I created a triangle for each of the variables. I have a triangle for u, and I have a triangle for v. So here's the triangle for u, it's yellow, and the triangle for v is blue. And the way that I got these triangles, it says that sine of u is equal to negative 3/5. Well, remember that sine is equal to opposite over hypotenuse. It's also equal to y over r. And it says that sine is between 3 pi over 2 and 2 pi. So what I did is I actually drew a unit circle just to kind of give me some reference. It says that it happens between 3 pi over 2, which is about 270 degrees. I don't know why I said about, and 360 degrees, or 2 pi, which means it has to be in the fourth quadrant. If it's in the fourth quadrant, that means y is going to be negative and x is going to be positive, which means sine is positive, cosine is positive, sine is negative, and the radius is always positive. I did the same for the other one here. If cosine of v is equal to 15 over 17, and it says v is between 0 and 2 pi, I drew a circle here. If I'm between 0 and 2 pi, I have to be in the first quadrant, which means x's and y's will be positive. After that, I used the identity. I knew that tangent of u plus v is equal to this whole thing here. So I said 1 over the whole identity. And notice how I highlighted u's and v's as being yellow and blue, just to help me with my triangles. So after that, I went ahead and kept it, keep it, switch it, flip it. It's kind of hard to put in the past tense, but I did a keep it, switch it, flip it, which means I said 1 times the reciprocal, which happens to be this. All I need to do after that is use my triangles to take all of the values. So I'm going to say 1 minus the tangent of u. So I'm looking at, hey, what's the tangent of the yellow triangle? Times the tangent of v. What's the tangent of the blue triangle? So if you use your calculator here, what you're going to get as an answer, and hopefully I'm remembering this right, I think it was negative 85 over 13. But I do not remember entirely. So I really hope that that is right. Give me a second. I'm going to pause and check. All right, guys. It's a good thing I pause and check because my memory is obviously not that good. It's negative 84 over 13. And so the solution here will be negative 84 over 13. All right, so if you're still struggling with Webassign by the end of this video, please just send me a message on Remind and we can find a time to either meet today via Google Meets, or you can put your questions onto ClassKick and I will answer them. Just make sure you raise your hand. All right, I hope you guys have an awesome day and you guys have a lovely break if I don't see you.